This is lecture 8.1, function operations. A function is a specific type of equation. A function is expressed as f of x or g of x. Sorry about that. I'm making it all wobbly. There we go. Okay, so a function here is f of x right there. That is f of x. Okay, now it's written this way because you have to know that whatever is here in the x position is being plugged in, anywhere that you see an x. This is the definition of a function in function notation. So no matter what is in there, whether it's a number, a variable, an expression, it could be a binomial, it could be lots of things, whatever is in there has to be placed in every position. So the way I look at this is, this would be f of is equal to whatever it is squared plus 5 times whatever it is minus 7. In this case, it's a 2. So we put a 2 there, a 2 there, and a 2 there. 2 squared is 4, plus 5 times 2 is 10. Well, that's 14. Minus 7 gives me 7. So my answer was 7. Okay. Now again, this is going to be 1 over whatever is inside of the square root. Not square root, sorry, inside the parentheses. In this case, it's a 0. Well, you can't divide by 0. Only God can divide by 0. Therefore, we call it undefined if you have a 0 in the denominator. Now, on this one, whatever is in there squared minus 11. Sorry, my handwriting is bad because I can't rest my wrist. So 6 squared. 6 squared is 36 minus 11. So this is the square root of 25, which, as we know, is 5. So that's my answer. Okay, this is function notation. We're going over this because this is very important to what we are doing today in regards to function operations. Okay, now I've got to shift down to my next slide. Oh, no, that's right, both of them there. Okay. And now, there we are. Okay. All right, this is function operations. Now, notice this is a different way of writing this, okay? Notice that the f plus g is in the right? Okay, this is a highlighter. F plus g, all right? F plus g is inside parentheses. So it's f plus g of x. Now it's going to look like it's multiplication, but it actually isn't. It's saying the function that is the sum of f and g with x plugged into it is equal to. That's what that actually is saying. It's not multiplication. If you think it's multiplication, you're going to mess up later on. Because there's other things going on that it's going to be different. So it is not multiplication. But what this means is f of x plus g of x. Okay, so f of x plus g of x. All right, subtraction. Now instead we have a subtraction right there. All right, and again, it's the subtraction of the two functions. This is the multiplication of the two functions. For division, notice it's f over g of x. which becomes f of x over g of x. And what we're going to do is rewrite this in this second form every time. We're going to rewrite it in those forms so that you can put it together, so you can start plugging things in. All right. Oops, sorry. Next slide is straight down. I was about to switch pages. There we go. All right. The domain of the resulting function is the intersection of the domains of the two functions. Now, for those of you who aren't sure what intersection means, it means overlap, okay? So it is where the two domains overlap. We'll go into that further. The domain of the resulting function may also be limited by the fact that the division by 0 is undefined. Okay, so we'll practice some of these so that you can understand this. All right. All right, these are function boxes, and you may have seen them before, you may not, I don't know. But this actually does help you understand what a function box does. So, if I put a 4 into a function, I'm going to go back to a pen. If I put a 4 into a function, I apply the function, and then out's going to come the answer, which is 25. 4 plus 1 is 5, squared is 25. Okay, whereas if I put 4 into a different function, a different number will come out, x minus 2. That's 4 minus 2 is 2, so that's what comes out, 2. Now, if I add them together, I get 27, 25 plus 2. That is the same as adding the two functions. This makes the addition and subtraction and even the division much easier. An operation with two functions can be written as a single equivalent function. Okay, we'll be doing that as we go. All right, here's example 1. Write the function rule. I want you to notice what we're doing here. What are the instructions? You're supposed to write the function rule for f plus g of x. All right, so that's f of x plus g of x. Well, what's f of x? F of x is x plus 1 squared, and there I have it. G of x is x minus 2, so g of x gets substituted out for x minus 2. All right, I square this. I can't add them until I take care of that square, the parentheses there. So I get, when I square it, x squared plus 2x plus 1. And it's still plus x minus 2. Well, I have a plus x and a minus 2, so I subtract x. No, sorry, so I add the x, right? So I have an x and a 2x, and that gives me a 3x. I have a plus 1 and a minus 2, so that gives me a minus 1. So my function, this is f plus g of x. Okay, now this one has absolutely no restrictions on domain or on range. Therefore, actually it does have it does actually have a restriction on its range. The domain of a parabola is all real numbers. The range is always greater than or less than k. In this case, k was minus 1. Here it was plus 1. The linear equation, x minus 2, had no range restriction. But the point being that negative plus 1, anything below plus 1, right? So let me draw a little sketch here. Actually, I can draw all the way down. This is going to have a vertex that's going up at plus 1. Okay? Now, so therefore, I will never have a y less than that. So minus 1, I would then subtract 2 from it, so that makes minus 1. So now my minus 1 is my range. So my range is all y values such that y is greater than or equal to -1. So that would be my range for A. All right, f minus g of x. That's f of x minus g of x. So we have f of x and g of x, just like the previous one, except for now we have a subtraction. The thing is, and you have to be really careful of this negative has to distribute to both of these. So it's going to become a minus x plus 2. So I have 2x minus x. Sorry. So I have 2x minus x gives me x. And then I have a 1 plus 2, so I have a plus 3. So you can see it's very different than the addition. Okay, so this is going to give me then x squared plus x plus 3. All right, moving. Okay, if f of x is equal to x plus 1 squared and g of x is equal to x minus 2, write the function rule. Okay, this is the same problem. Notice still example 1, but these are c and d. So now I have an f times g of x and an f divided by g of x. Okay, so f times g, I'm going to have to multiply these two together. To do that, sorry, let's go to this. Okay, so I'm going to multiply this together. To do that, I'm going to have to take my x plus 1 squared and FOIL it out to get the trinomial x squared plus 2x plus 1. Now I've got to multiply. So I have x squared times x, which is going to give me x cubed. And then I have x squared times minus 2. So that's minus 2x squared. And I have 2x times x, which gives me 2x squared. And I have minus 4x. When you see the screen wiggle a little bit, some part of my hand has hit the screen, and so it's doing weird things when I do that. So I have to be careful. All right, and then I have plus x and a minus 2. Well, I have a minus 2x. So you have a minus 2x and a plus 2x. So they're going to go away. They cancel each other. On the other numbers, though, I'm going to have my x cubed. Oops, let's get off of yellow. That's hard to see, harder than even the green. I have x squared, and then I have to add x to negative 4x. So I'm going to have a negative 3x, and then my minus 2. So I have x cubed. I have minus 3x and minus 2. All right, now on this next one, there's some restrictions because we're dividing by something. So g of x cannot equal 0. If g of x equals 0, so what we're saying is that g of x has to be greater than 0 or less than. Now, what we're saying is it just can't equal 0. Okay, so x minus 2 cannot equal 0, so x cannot equal 2. That's where this constraint comes from. All right, so f of x over g of x, that's what we've got here. We plug in the values. We plug in f of x, and then we plug in g of x, and we're done. There's nothing we can do to simplify this. So we're done. It's really easy to do divisions. You just have to be careful and include the restriction because g can never be 0. Okay. I'm going to go back and just double check. I was at, okay, I'm going to skip the slide. Sorry about that. Okay. Oh, I lost it. Oh, gosh. No, I'm still playing. Okay. All right, so we have graphs of these combined functions. F plus g of x. If you can plot f of x and g of x, it helps. Because you've got f of x, was this one. Because, sorry about that. You need a pen there. Okay, so this was f of x because it was a parabola. Okay, and this is g of x because it was just a line. All right, if you notice what happens is we take this number, we take that number, we add them together, and we get something in the middle because one's negative and one's positive. Once you get to everything being positive, it takes off. Okay, on the second one here, you're doing basically the same thing. You're adding these numbers. Oh, I'm sorry, you're multiplying. By multiplying these two numbers, I'm multiplying by 0, so zeros become 0, no matter what. Okay, so that's why I've got crossings in two places. Okay, and here it's as much above as below, etc. All right. Now, we have something called a composition of functions, and so you really need to pay attention to this section because the composition of functions can be a very complex, until you get the hang of it, skill. Okay, to combine, you compose two functions, all right? It's denoted with a 0, and it's called f of g of x, sometimes referred to as fog. The f of g of x. Okay, it's written this way. All right, but we will rewrite it to f of g of x. This is where that whole concept of whatever in the parentheses gets plugged in wherever x is really, really, really important. Okay, expressing f circle g of x as f of g of x is helpful when evaluating for a given value of x. First, evaluate the inner function, in this case g of x. Then, use the results to evaluate f of x. On the function boxes we saw before, basically what's happening is some number is going into g of x first, and it spits out a number which immediately goes into f of x, and out comes your answer. Okay, so you plug the number into g of x, which is the interior one. Notice right here, it's the interior. And then you plug that answer into f of x. All right, let's see how this works. All right, evaluate each expression when f of x is x squared minus 3 and g of x is 2x plus 1. Okay, so remember we rewrite this as f of g of negative 2. So first we're going to find the interior one. Okay, let me fix that. This should be a 1. First, we find g of minus 2. Well, we plug that in because it's 2 times whatever x is plus 1. So it's 2 times minus 2 plus 1. Negative 4 plus 1 is negative 3. Then we take this negative 3 answer and we plug it into f. All right, now x is squared, so it becomes negative 3 squared minus 3. Negative 3 squared is 9. Minus 3 is 6. So our final answer would be 6. All right, we'll try that on this next one. G of f of 3. Well, remember, the interior one is going to be this one. So we do this one first. F of 3, so f was x squared minus 3. So I have 3 squared minus 3, which is 6. Okay, and then we plug that into our g right here. So now I have g of 6 is equal to, well, g was 2 times x plus 1. So I have 2 times 6 plus 1. 12 plus 1 is 13. So now my answer is 13. Okay. We're having fun now. All right, next slide. Okay, the composition of functions can be written as a single equivalent function. Usually, f of g of x does not equal g of f of x. So this is not commutative. You can't just flip them around however you want to. You have to do them in order. All right. So what we've talked about so far is the compositions of functions given a specific value. So now we're going to do it without the specific value and just write the single equivalent function. So what we're going to end up with is something like f of g of x is equal to like x squared plus 3x minus 4. Okay, you're going to come up with a function, something like that. This is just an example of the type of thing we're going to be looking for. Okay. All right, so if f of x is x squared minus 3 and g of x is 2x plus 1, write a single function rule for the composition of f of g. All right, f of g of x is my f of g of x. So that's f of, well, g of x was 2x plus 1. So g of x is 2x plus 1. Now that goes wherever my x was. My x was squared. So I now have 2x plus 1 squared minus 3. So I have to FOIL that out. If I FOIL that out, I'm going to get... Whoa, sorry about that. I forgot to switch to the pen. Okay, so if I FOIL that out, I'm going to get... Nope, I don't want to print this. I'm going to get 4x squared plus 1 times 2 is 2, times 2 is 4, plus 4x plus 1, and then I still have this minus 3. So that's where this equation right here is coming from. So that is the single function rule. Over here on the next one, it's back the other way around. Now it's g of f of x. So what's inside is f of x. So f of x is x squared minus 3, so we plug that in. That goes everywhere x is. That's where the x was. 2 times x squared minus 3. So I distribute the 2, 2x squared. Then I get a minus 6 plus 1. That's what gave me the minus 5. And that is the single function rule for g of f of x. Okay, next page. Come on, there we are. All right, given these real number functions, write the function rule for f of g of x and state its domain. Okay, so now we're going to get into domain and range. It's a little dicey. Okay, remember, this is my g of x is inside. So I have f of g of x. Okay, so g of x is inside. G of x is the square root of x minus 3. So I have f of the square root of x minus 3. Now, in f of x, that's in the bottom, and it's squared. So I plug this square root of x minus 3 into the bottom, but notice it is squared from f of x. Well, I'm squaring a square root, so that goes away, right? It cancels. So I end up with 1 over x minus 3. Ta-da! Okay, so this would be your single function rule. Okay, now we also have to state its domain. I'm going to see if that was on the next. Yes. Okay, so here's our equation right here. Okay, this is our function that we're working on. Now, what is its domain? Okay, the domain of g, was x had to be greater than or equal to 3. Anything else would be a problem because I have got that square root, and I can't square root a negative number, not and be in the real world. Okay, so my domain on G is x greater than or equal to 3. Now, in f of g of x, x cannot equal 3 because I can't have the denominator equal to 0. So that's why x cannot equal 3. Now, the domain for the combined function, the composed function, is x has to be greater than 3. Notice this had an equal to before, but because of this, I have to get rid of that equal to and just make it x greater than 3. That is my domain. Oops, no. All right, so now you're down to homework. And there's your homework.